So in our next section, we're going to talk about the types of reactions. So we looked at balancing the chemical equations. Now we need to figure out what type of reaction is going on. First up here, we have synthesis. Synthesis just means that you're combining two or more substances and you form a compound. Only one product is formed. And so when you synthesize something, you're basically just putting two things together. That's why we write it here in the generic form of A plus B equals AB, right? So it just means like if I had two singular atoms or molecules, they come together to make a new compound. So all of your ionic bonds pretty much and your covalent bonds, that was a synthesis of sorts because it's combining just these two things and you get one product out of it. The opposite of synthesis is decomposition. So now you're working the other way around because a lot of times you can go back and forth between these two and certain things will break down shortly after they're made. They only last for a certain amount of time. And so it's the breaking down of something to make more, two or more substances, right? So you have one reactant breaks down in order to make two products. Usually most require heat, light, electricity, some sort of great amount of energy to break them back down, okay? So here's an example. This is more commonly known to you as hydrogen peroxide. A lot of you put it on boo-boos to clean it out and everything. But anyway, it's just two hydrogen and two oxygen mixed together to make hydrogen peroxide, right? It breaks down pretty regularly. And so you'll get that bubbling that you see from hydrogen peroxide is just O2 gas leaving it, and what's left is water because you're getting these oxygen molecules breaking down. It breaks down more because it's unstable, but it can still work by putting something in it of heat. If you try to heat it up, all of the oxygen will go out instantly. And so it needs to be colder to stay stable, and then you add some heat and it breaks apart. So our generic form is you have AB breaks down into A plus B. Next, we have single replacement. So in a single replacement, it's just like the name suggests. You have one person coming in, knocking out something else, okay? So normally you're going to have a compound of some sort. You have to have a compound in some sort. And then a lot of times it'll be a singular atom or singular molecule, right? And it'll come in and it'll knock out one of the portions of it, and so you're there. So notice this down here, this is zinc, and this is hydrochloric acid. So hydrochloric acid is one of those that breaks down pretty easily. It dissolves things, right? Well, one of the ways it dissolves things is it releases hydrogen. And then it's going to bond with the zinc, and so you would get this zinc chloride and just hydrogen gas coming off of it. That's also why it bubbles to gas. But see how the zinc comes in, pushes the hydrogen out. That is a single replacement. One thing replaces one other thing, and you still have one item and a compound on either side. Best way to represent that generically, A plus BC equals AC plus B. Then, of course, double replacement. Think about this. Somebody related these to switching partners at a dance. And so they're doing the do-si-do a little bit. So you have two compounds that come together, but they might like the other partner better for them, and so they swap it around. So generic form AB plus CD equals AD plus CB. They switched partners. The D and the B switch places. So if we're looking at this, this is a base. This is a potassium hydroxide coming with copper sulfate, and the sulfate and the hydroxide are going to change places, and so you end up with potassium sulfate and copper hydroxide. And then there's my personal favorite, combustion. Now, combustion's a little bit different because basically, boom, we get explosions. And really it's burning, but the way anything burns is it has to have oxygen. Thus, in a oxygen-depleted area, you have no real fire. And so it's going to produce heat. So this actually should have a triangle if you remember our symbols earlier. But you're going to have a hydrocarbon. Hydrocarbon is any molecule made up with hydrogen and carbon in it. And so this can be generic. The amounts of them, you notice they're put as X as Y because we're not sure which ones. But it has to combine with O2. That oxygen is what makes the combustion. It's what allows it to burn. And then your products are always going to be the same thing. You're always going to get a carbon dioxide and water. Carbon dioxide and water. And so notice there's not really a great generic version of this one because so many things are already set in stone. You have to add a hydrocarbon with oxygen, and you're always going to get carbon dioxide and water. So notice down here, this is basically a type of fuel. Let's see, that might even be methane. Goes in with O2, you get your carbon dioxide and water, and that would be a combustion reaction. These three things are really what you look for to make sure you have a combustion. It does have to have a hydrocarbon over here, but that's pretty easy. If you have the rest of these things, that's probably going to be a hydrocarbon. And that's all the types of chemical reactions you're going to have to list that we're going to look at today.